It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
When we imagine life on other planets, we have to imagine that the environment on those planets will determine what the creature may look like.
Yes, we expect James Webb to make great discoveries.
This is the first time we get to orbit Mercury.
Mercury, the smallest planet in our solar system, has long been a source of fascination for astronomers and space enthusiasts. Nestled closest to the Sun, its proximity and small size made it difficult to study, leaving much of its nature a mystery. However, recent missions, particularly those involving NASA's Messenger spacecraft and the upcoming Bepi-Colombo mission, have begun to peel back the layers of Mercury's enigmatic character, revealing a planet far more complex and surprising than we ever imagined. The discoveries made about Mercury are nothing short of extraordinary, ranging from its unusually large core and mysterious magnetic field to the shocking presence of water ice and potentially even organic materials on a planet where life seemed impossible. Mercury's story begins with its surface, a desolate and harsh landscape that was first glimpsed in detail by the Mariner 10 spacecraft in the 1970s. Mariner 10 showed us a rocky planet with bulges similar to our Moon, but unlike the Moon, Mercury has a surprising magnetic field, one of the mysteries that has puzzled scientists for decades. The Messenger spacecraft, accompanying Mariner 10, took a closer look at the planet, capturing more than 200,000 images. These images showed a fascinating world with abundant magnesium and manganese, especially on the dark side. The discovery raised questions about the Earth's processes that gave rise to these variations and challenged scientific theories. Mercury's magnetic field is one of its most puzzling mysteries. Although a small, slowly rotating planet, Mercury's magnetic field shocked scientists due to its magnitude and the slowness of its rotation. Scientists believe this magnetic field originates from a unique process in its liquid core, which is associated with Mercury's unusual orbit and rotation. Unlike Earth, Mercury's magnetic field is not polarized, and it extends to about 1% of the radius of the planet. This unusual phenomenon may be due to a rough crust that changes the flow of heat around the planet. Additionally, the magnetic field is particularly strong in the northern regions, a phenomenon not seen on other planets in the solar system. However, the most surprising discovery by Messenger is the existence of water ice in the polar craters of Mercury, which are constantly shaded by the sun's rays. These craters remain cold enough to hold ice no matter how close the planet is to the sun. The discovery was a surprise, and scientists wondered if these layers of ice contain other materials, including organic compounds. The discovery of these dark deposits of organic material, possibly the remains of comets or asteroids, has raised the possibility that Mercury may hold clues to the origin of life in the universe. But Mercury's secrets don't stop at the surface. Beneath the rocky exterior is a core that is equal parts fascinating and confusing. Mercury's core is 85% of the total volume, much larger than Earth's core, which is only 15% of Earth's volume. One theory suggests that Mercury was a giant planet that lost most of its outer layers in a massive collision early in the solar system's history. This hit-and-run phenomenon may explain the great and ironic movement that continues today. The size and composition of the core are also important in generating Mercury's magnetic field, adding another layer of complexity to this fascinating planet. Adding to this mystery, Mercury's core is believed to be mostly liquid, with a larger solid layer about the size of the planet's solid core compared to Earth's. This unusual core structure may contribute to the planet's unique magnetic properties. Additionally, current information suggests that Mercury's mantle is thinner than previously thought, which affects the shape of the planet's surface and how it absorbs heat. In 2012, Messenger data showed signs of ancient volcanic activity on Mercury's surface, suggesting that there may have been more geological activity than scientists had thought. The surprises continued in 2020 when scientists found evidence of an ancient magma reservoir beneath Mercury's surface. This ancient magma ocean played an important role in the formation of Earth and the interior structure of Mercury. The findings suggest that Mercury's history was more dynamic than previously thought, with volcanic activity and a semi-molten core contributing to its current state. Another surprising finding from MESSENGER's 2022 data is the presence of nitrogen beneath Mercury's surface, suggesting that the planet may have lost more of its form over time. Mercury's harsh environment adds to the mystery. The planet experiences some of the most extreme temperature swings in the solar system, with daytime temperatures reaching as high as 86 degrees Fahrenheit and nighttime temperatures dropping as low as -292 degrees Fahrenheit. These drastic changes come from Mercury's thin atmosphere, or exosphere, which does not regulate the planet's temperature. The exosphere contains gases that continue to flow into space, replenished by solar winds, radioactive decay, and meteorite impacts. The special day and age of Mercury also contribute to its unusual appearance. Earth takes only 88 days to revolve around the Sun, making a year shorter than ours. However, one revolution on its axis takes 176 Earth days, meaning that a day on Mercury is twice as long as a year. This unusual rotation pattern, known as the 3:2 orbital resonance, is caused by the Sun's gravitational pull, which synchronizes Mercury's rotation with its orbit. As a result, one side of the planet faces the Sun for a long time, causing extreme heat, while the other side is left in the dark and very cold. This unusual rotation creates amazing features on Mercury's surface. If you were standing on Mercury, you'd see the Sun rise, get bigger, then stop and move backward before continuing through the sky. These unusual motions of the Sun are a result of Mercury's slow rotation and its speed around the Sun. The rotation of the planet and the cyclones also create heat poles, areas on the surface where the Sun shines and stops. These areas generate a lot of heat. Despite its harsh environment, Mercury has managed to retain water ice in permanently shadowed craters at its poles, a discovery that has intrigued scientists and sparked questions about the possibility of life. The existence of organic materials in these craters further adds to the mystery, suggesting that even in such an extreme environment, there might be remnants of the building blocks of life. These findings challenge our understanding of planetary science and hint at the possibility that Mercury, once thought to be a barren and lifeless world, might hold clues to the origins of life in our solar system. As we continue to study Mercury, it becomes increasingly clear that this small planet is full of surprises. From its massive core and unusual magnetic field to the presence of water ice and organic materials, Mercury defies expectations and challenges our understanding of the solar system. The upcoming BPI-Colombo mission, set to arrive at Mercury in 2025, promises to reveal even more about this enigmatic planet, potentially uncovering new secrets that could change the way we think about our place in the universe. In conclusion, Mercury is a planet that, despite its small size and proximity to the Sun, holds a wealth of mysteries waiting to be uncovered. The discoveries made so far, ranging from its unusual core and magnetic field to the surprising presence of water ice and organic materials, suggest that Mercury is far from the simple, barren world we once imagined. As new missions and research continue to explore this intriguing planet, we can only wonder what other secrets Mercury might be hiding beneath its cratered surface. The journey to understand Mercury is far from over, and each new discovery brings us closer to unraveling the mysteries of the smallest planet in our solar system. One of Mercury's most fascinating features is its exosphere, a thin layer of atoms and particles that clings to the planet's surface. Earth's atmosphere is different. Mercury's outer layer is very thin, almost a vacuum. This exosphere is mainly composed of oxygen, sodium, hydrogen, helium, and potassium, which are continuously replenished by various processes. Solar winds remove atoms from Mercury's surface, blasting micrometeorites onto the planet, and radioactive decay of elements in Mercury's crust enters this fragile mantle. This exosphere disappears into space, creating a dynamic and ever-changing relationship between Mercury and its hostile space environment. Another fascinating feature of Mercury is the craters, which are rocky, massive tectonic structures that cross the planet's surface. These craters, which rise 3 kilometers high and stretch hundreds of kilometers long, are thought to have formed as Mercury's core cooled and collapsed over billions of years. The shrinking of the core caused Mercury's crust to bend and create these amazing rock formations. Studying these sharp features will not only help us understand the history of Mercury but also help scientists understand the thermal evolution of the terrestrial planets. The appearance of these features indicates that Mercury's interior has been cooling and subsiding for a large part of its history, a process that continues today. Mercury's interaction with the solar wind sets it apart from the other planets. The planet's proximity to the Sun means it is constantly bombarded by the solar wind, a stream of charged particles emitted from the Sun. This bombardment interacts with Mercury's magnetic field, creating a magnetosphere that is much more dynamic and complex than first predicted. The interaction between the solar wind and Mercury's magnetic field creates a powerful magnetic storm, which helps form the exosphere. These interactions are not fully understood and are the subject of ongoing research. By knowing the planetary conditions of Mercury, scientists can gain valuable information about space weather and its effects on other planets, including Earth. The planet's surface is equally active, with large plains of solid lava indicating that volcanism played an important role in forming its surface. Messenger data show the presence of large, flat-looking plains formed by ancient volcanic eruptions. These volcanic plains, similar to the Moon's craters, indicate that Mercury was inhabited in the past by eruptions that covered large areas of the surface with lava. The discovery of these plains has raised questions about the planet's thermal evolution and the internal processes that gave rise to widespread volcanism. The age and distribution of these plains provide crucial clues to Mercury's past, helping to piece together the timeline of its volcanic activity. In addition to volcanism, Mercury's surface is marked by a large number of impact craters, including the enormous Caloris Basin, one of the largest impact craters in the Solar System. The Caloris Basin, with a diameter of about 1,550 kilometers, was formed by a massive impact early in Mercury's history. The force of this impact was so great that it caused the formation of concentric rings and areas of weird terrain on the opposite side of the planet, where seismic waves from the impact converged. Studying craters like the Caloris Basin provides valuable insights into the history of the early solar system, particularly the period known as the Late Heavy Bombardment, when the inner planets were frequently bombarded by asteroids and comets. Finally, the orbit of Mercury itself is a place of great scientific interest. The planet has a circular orbit, which varies greatly, resulting in different distances from the Sun throughout the year. This erratic orbit, along with the slow rotation, leads to the Sun's unusual appearance on the planet's surface. Mercury's orbit was also important in confirming Einstein's general theory of relativity. Observations of Mercury's perihelion, the point at which its orbit around the Sun reaches its closest, could not be explained by Newtonian mechanics alone. Accurate measurements of this cycle provided one of the first confirmations of general relativity and indicated that Mercury played a crucial role in one of the major advances in modern physics.